how's it going? And welcome back to another ASMR video. Tonight's video is a bit of a different fun style video tonight. And tonight I am going to be doing some fun maths tricks and proofs and just cool little brain teasers, all to do with maths. And this is simply because I am a maths student, that is right, for those who don't know, and I always find myself learning these little tricks, and I just thought it would be fun to share some with you guys tonight. Now, I've actually done a video similar to this before quite a while ago, so I'll pop the link for that on the screen and in the description. But for this video, I'm going to be using this cool wee whiteboard that will be very fun for me to draw some things on it. We can rub things out easily, and it will just look very, very nice. So if you are excited, be sure to like the video. If we can get 150 likes, that would be incredible. And while you're at it, if you're not already, be sure to subscribe. Only a small percentage of people who watch these videos are actually subscribed. So for those who aren't, I know who you are. Just kidding, guys. But real quick, before we jump into this, I just want to say that I cannot take credit for all of these things that you will see in the video. In fact, I will put the links in the description to the original sources for where I learned these wee tricks. And if you guys don't already, be sure to follow me on Instagram and Twitter. If you don't, they'll be on the screen now. You can follow me with the links in the description as well. It's where I'll post really cool behind the scenes things and just post a little bit of what I get up to during the day. And one final thing, just to get you guys excited for the video. Later on in the video, I am going to be proving a wee mind-reading mentalism trick that I used in one of my card magic videos recently. So be sure to stay tuned for that. It's going to be a really fun video. And without further ado, let's jump straight in to the video. Okay guys, so I hope you all really liked that fun wee intro. It took me a while to make, and I do apologise. I am not the greatest of artists or drawing pictures, really. I just thought it would be a fun wee intro to make. I also apologise for any reflections of cameras and microphones. I had a bit of a struggle getting good lighting for this video. If only you guys could see my setup right now, you would be laughing. But anyway, this first proof that I'm going to be doing is a very, very fun one. I thought we'd start off nice and fun, and I am going to prove to you guys how 1 is equal to 2. Now I know straight up you guys are probably thinking, what the hell, there's no way 1 simply doesn't equal 2. Well, today I'm going to prove to you, using a wee fun algebra method, how 1 can equal 2. So let's start off by letting A equal B. So some number A equals the same as B. Now don't worry if you're not a huge math whiz or weren't amazing at math. This should hopefully all make sense as my camera tries to focus. So let's say A equals B. Well, with basic algebra we can do a few things to this. We can multiply both sides by A and say that A squared equals A times B, which we'll just write as AB. Now, if we subtract either number from the same side, they will still be the same. things. So if I do a squared minus 1, that's the same as ab minus 1. It doesn't really make a difference. So in our case, we are going to subtract b squared from both sides. So we're going to have a squared subtract b squared equals ab subtract b squared. And now we can do a bit of algebraic factorizing here. A squared minus b squared is the difference of two squares, which is a plus b multiplied by a minus b. You guys can work that out on your own to see that that is correct. And on this right side here, we have a common factor of b, so we can take b out and say that's the same as b multiplied by a minus b. Now we have a common factor on both sides. We have this a subtract b on both sides, so we can simply cancel both of these out, and we now have that a plus b is equal to b. But we said before that a is equal to b. So if a is equal to b, then b plus b is also equal to b, which is the same as 2b equals b. And then here we can divide both sides by b, and we can see that 2 is equal to 1, as this is technically 1b. Divide both sides by b, and we can see that 2 is equal to 1. So that was a pretty crazy proof to start with. Now obviously 2 does not equal 1. If anyone would like to say in the comments how they think this is done, please do let me know where any algebra might be impacted here, where it might not work, but I thought that was pretty fun. We can see that 2 is equal to 1, and that was pretty crazy. Let's move on to something a bit more fancy. Now this next fun proof is something that I was actually really intrigued in, and it's something that's very, very interesting, and it's nice because it clashes with my favorite thing in maths, which is geometry. And specifically, we are going to be talking about the area of a circle. And I think this is a very fun proof, as when we learn what the area of a circle is, which we'll get into in a moment, we aren't always told or taught why the area of a circle is what it is. And that is what I'm about to do right here. I'm going to be showing you guys exactly why the area of a circle is what it is. Now for those who don't know, circles have many, many properties. We have things such as its radius, which we call r. We have the diameter of the circle, which is from one end to the other, directly opposite. The radius is half the distance from the middle to the end. We call the diameter one end to the other. And we also have this circumference, which is the length all the way around the outside of the circle, and of course the area, which is all the inside space. Now, one of the first things we are taught is the circumference of the circle, or any circle, is given by this formula here, pi times the diameter, or we can rewrite this as pi times pi 2r, but we'll rewrite this as 2 pi r. It's the same thing because 2 times the radius is the diameter, so the diameter is just 2r. Hopefully that makes sense for those who don't know. Now, when we take the area, we are told that the area is pi r squared. But why is this? The 6, blah blah blah. It's an endless number. It is a never-ending number, and it is this ratio between the diameter or the radius that can give us properties of a circle, and it's a very cool number. And it's very important for when we do this proof. So let's take this area, the area of a circle, which we know is pi r squared. And I'm going to be showing to you, with my very poorly drawn circle, why it is pi r squared. Let's try and get that a bit better. There we go, that'll do. Now, if I take my circle and I break it up into lots of little circles, so let's try my best to draw a few wonky circles inside this circle. Okay, now these circles are quite thick in between each circle. It's important that we do them thick to start with, but in a moment we're going to make these very, very thin, so we'll have loads and loads of circles in between them. And if I take my circle and I snip it with some scissors, right along from one edge of the circle, from the outer side, right to the center, like so, and I actually snip it along here, like so, we will cut the circle into lots of sort of lengths of spaghetti. In fact, let's take this little length right here. You can see if this circle is snipped, it will actually, when rolled out, if we imagine it as a string of spaghetti, it will roll out into something that might look like this. It will be quite small. This length of it here will be the circumference of this little inner circle. Now if we take the next circle consecutively, so this time we're working with this circle here, and we unravel that circle next to our first inner circle, we might get something that looks like this. It will be slightly longer as the circle is bigger, and if we do this for all our circles, we'll get this sort of shape that keeps getting bigger and bigger and bigger each time, like so. Now, this is where we're going to use our imagination a wee bit. If we imagine that each circle is very, very thin, like as thin as a sheet of paper, so there's millions and millions and millions of circles in our big circle. They will be so thin that you can't even see the difference. We'll have so many circles that if I was to draw this, it would be impossible. In fact, the circle would actually look like it is almost colored in. We'd have that many circles inside this. And if we were to do this, the difference in gap between each height of these ones here, so you can see we've got this bit of a step pattern here. If I was to do really, really small circles in here, our shape would look very, very close to a triangle. And you can see this as they will keep getting bigger and bigger each time, but there'll be so many of them in here that you won't be able to see this step pattern that I was talking about. It will almost just look like a straight line across the top here. Now let's inspect this triangle. For those who don't know, we say that an area of a triangle is a half base times height. Now, what is the height of our triangle? Well, it's going to be this very, very thin circle on the very, very end, and if we take this, we know the height of this is simply, well, it's going to be their circumference, isn't it? And this is what we're told up here, 2 pi r. And what is this base of our triangle? that's simply going to be the radius of our circle, as we are taking all the bottom parts of each of our inner circles. So our radius is just going to be r. And if we plug these values into our equation for the area of a triangle, we get a half times the base, which is r, and times the height, which is 2 pi r. And we can simplify this. Well, the half is going to cancel with the 2, and r times r is just r squared. So we have pi r squared. And this area here is the exact same as the area of our circle, as we took all these circles from our big circle. And that is just one fun proof of how the area of a circle is pi r squared. Now for this next fun proof, we are going to be talking about a concept in maths known as factorials. And this is a very fun concept that some of you might not have heard of before. And it's actually a bit of a pun that I've written right here, as factorials use the exclamation mark symbol when doing them. Now, what does this exclamation mark symbol mean? Well, you might think it's when you're shouting something or exaggerating something. But no, in maths, if we take this exclamation mark symbol and put a number in it, say 4, we say that this is called 4 factorial. But what does this mean? Well, this simply means we take our number that we've got, in our case it's 4, and we multiply it, going down each number before it. So it's going to be 4 multiplied by 3, multiplied by 2, multiplied by 1, and we stop at 1. As if we were to multiply that by 0, we would just get 0. So we consecutively subtract 1 from our number and multiply it as we go down. So 4 factorial is 4 times 3 times 2 times 1, which we can see is going to be 24. And we can do this on a calculator for much, much larger numbers. As we see, if we take 4, try and get this so you guys can see it. In fact, I'm going to zoom in. If we take 4 and we use the factorial symbol, we can see on the calculator that it gives us 24. And we can do this for much, much larger numbers, such as, well, the larger the number is, the bigger our answer is going to be. So we can see that 10 factorial gives us this number here, 362,880, which is only 6 numbers greater than 4, but it's almost 100,000 times 24, which is crazy. Now, if we take, say, 100 factorial, we can see that we might not even get an answer, we get an error, as the number is just so large. We say that it grows very, very fast. Now, let's go back to this 4 factorial, and we can use this to help us prove what, say, 0 factorial is. Now I know what you're probably thinking, well, we stopped at 1, so how can we work out what 0 factorial is? Well, you probably think it's just gonna be 0, right? Well, you would be wrong. 0 factorial is actually That's nuts. How is that possible? Well, let me show you exactly how it is possible. Let's take the numbers between 4 and 0. We have 3, 2 and 1. And let's work out what the factorials of these are. Well, 3 factorial is 3 times 2, which is 6, times 1, which is just going to be 6. 2 factorial is 2 times 1, which is 2. And then 1 factorial is 1 times 1, which is going to give us 1. So how is 0 factorial possibly equal to 1? Well, let's take a look at these answers we got. What do we do to get from 24 to 6? Well, 6 goes into 24 4 times, so we're simply multiplying 6 by 4 to get to 24. In fact, I should probably write divided by 4. How do we get from 6 to 2? Well, 2 goes into 6 3 times, so here we are dividing by 3. And I think you can see where this is going. How do we get from 2 to 1? Well, we just divide by 2. So, there's nothing to say that the next one between 0 and 1, or 1 and 1 in our case, we are dividing by 1. And what is 1 divided by 1? Well, that is just equal to 1, right? So therefore we conclude that 0 factorial is equal to 1, even though we cannot explain what 0 factorial is. So that is why 0 factorial is 1. Okay, now to round off the video, I thought it would be a very, very fun idea to explain a mind reading trick that involves a lot of maths that I did in one of my card magic videos. And I'm going to show you that clip right now. To begin this video, I am going to try and read your mind, your mind, your mind, your mind. So to do this, listen very, very carefully. I would like you to think of a number between 1 and 10. Any number you want. Have you got one? Now I would like you to multiply this number by 9. I'll give you a wee moment to do that. And once you've multiplied it, you will now have a brand new number. And with this number, I want you to add both the digits in the number together. If your number is a single digit number, just ignore this step. But for example, if you had 34, add the 3 and the 4 together to give you 7. So I'll let you do this now. Are you with me? Good. Next up, I would like you to subtract 5 from your new number. Have you done it? Awesome. And finally, I would like you to think of the corresponding letter of the alphabet with this number. So what I mean is, for example, A would be 1, B would be 2, C would be 3, and so on and so on, okay? Right, so are you thinking of a letter of the alphabet? Great. And I would now like you to think of an ASMR YouTuber who begins with that letter. in the comments down below if you are thinking of me. And for those of you who aren't, let me know who you were thinking of. But hopefully, I was the one that came to your mind. Okay, so hopefully you guys enjoyed that. It was very, very fun seeing what everyone said in the comments. If you thought of me, Dido ASMR, then shout out to you guys. But I am going to show you using maths how I got you to think of me. And I'm going to do this by taking you through each of the steps that I mentioned whilst doing this mentalism trick. And it's not really mentalism, it's just a fun magic trick at the end of the day. So let's go through each step. So what was step 1? So step 1 was to get you to think of a number between 1 and 10. Now you could pick any number, literally any number. It was a free choice. Let's say, for example, we go for my favourite number, which is 7. Not much going on so far. Step 2 is where the important step comes in. At step 2, I get you to multiply your number by 9. Now, whatever number you pick between 1 and 10, when you multiply it by 9, it comes in very handy for step 3, as no matter what number you pick between 1 and 10, when you multiply it by 9, so in our case 7 times 9 is 63, no matter what number you get here, when you add both digits together, you will always get 9. And let me show you that. If we pick a number between 1 and 10, let's call it x. 9x. When we get this number, we'll always add the digits together to get 9. As the 9 times table, let's go through each of our numbers. So let's say for each of the cases between 1 and 10, 1 times 9 is 9, 2 times 9 is 18, 3 times 9, 27, then 36, then 45, 54, 63, 72, 81, and 90. And if you add each of these digits in each scenario, so 9, 1 and 8, 2 and 7, 3 and 6, you can see you will always get 9. And it's important that it's between 1 and 10, as if I got you to pick, say, a number between 1 and 11, if you chose 11, 11 times 9 is 99. And here, 9 plus 9 does not give us 9. So that is why our first step involves picking a number between 1 and 10. Now, step 4 is where I fully take control of what you are doing. Everyone will have 9 at this stage. So in step 4, I simply get you to subtract 5 from 9. So everyone will be thinking of the number 4. This way, when I have the number 4, in step 5, when I get you to think of a letter corresponding to that number, where I say, for example, A is 1, B is 2, C is 3, and so on, your number, which will be 4 for everyone, will always give you the letter D. Always. As long as you did your maths correct up here anyways. And this will get you to think of an ASMR YouTuber beginning with the letter D. Now there are some ones out there. You've got Dr. Tingles or Donna ASMR. You could have been thinking of anyone, but coincidentally, my name, Dido ASMR, begins with the letter D, and I figured, well, if you're watching me, you could probably think of me. That was the aim, and I think it worked on about 90% of people So if you were in that 10%, hey, why are you not thinking of me? That sounds a bit weird, I probably shouldn't say that. But anyways, I hope you all enjoyed this video. It was just a bit of fun, and I decided it would be a very unique video using this whiteboard. So if you guys did enjoy, be sure to leave a like rating. And let's see if we can get 150 likes. That would be absolutely crazy. Anyways guys, thanks so much for watching. And I will see you all in the next video. Stay safe and good night guys.